I'll walk you through how we as a Symend use DBT to achieve operational efficiency and excellence. My name is Raman Singh. I'm an engineering manager in analytics and data. I have around 1 decade of experience in the world of analytics, end-to-end, from ingestion, data modeling, business intelligence, data science. And I consider myself too lucky enough because I've been using DBT for the last 7 years now. And I have seen the journey of how these tools have evolved in the market to where we are today, including Snowflake as well. So I'm going to share my journey and also the journey as a Symend, how we leverage these tools to operate where we are today. So we'll go through to explain about the Symend, the company, the challenges that we were facing with legacy stack and methods, how DBT came to rescue our life, the key accomplishments with DBT implementation, and throughout the journey, we learned some best practices and patterns that I would like to share, and hopefully this will help you guys as well. So what is Symend? So Symend is a truly SaaS-based company built on engagement platform. What our company provide is empowering our client to engage with their customers through behavior science, understanding their motives, their patterns, how they behave and respond to them. So we operate over 3 continents, North America, Latin America, and Europe. Our biggest customers are top financial institutions and telecommunications in North America. We help dealing with delinquent customers. So the customers which are being delinquent, and we prevent them to face consequences like credit damage and service suspension. How we operate on a very high level. So the customers provide us their data, the accounts they're dealing with, and then we segment the data against the situational archetypes. And based on the segments, we run engagement platform strategies, and then we measure the success and see how they're performing. And also, since this is all about engagement, data plays a huge role in engagement. We use data to understand how our different engagement strategies are performing, how customers are behaving, what are the different patterns which are working well and not, and how we can improve upon them. So this is a high-level domain design of analytics. So we operate in a microservices-based platform, which allows engineering as a whole to build and scale independently and yet cohesively. Primarily for analytics, we have 3 microservices: collector, refinery, and presentation. Collector is responsible of EL, extracting and loading. The tool we use is Azure Data Factory from Azure. And we have different data sources. We have blob files, we have SQL tables, we have some real-time data as well that we collect. And then we load the data into Snowflake, which is our data warehouse. Moving to refinery. So refinery is where we do all the transformations, data enrichment, munging, joining, cleaning, testing, and all that. And then the primary tool we use is, of course, DBT. And then presentation is where our clients are empowered to interact with the data and make decisions based on the data. We have different platforms like business intelligence. We use Looker, and now we are moving to Sisense as well. And then it also allows our technical users to come and run SQL queries and scripts on top of this data. So now I'm going to walk you through the challenges that we were facing with legacy stack and method. So before onboarding to modern tools like DBT and analytics, we were operating under a distinct pattern, which was good for a startup company phase. But as we started to scale, we started to face some issues. And then we realized that we have to change the way we're doing things. Otherwise, we won't be able to scale as the way we want. So we were using a monolithic pattern, and we had some challenges. The patterns was that we had no SDLC and CI/CD, which means that developers were building models, pushing it to production. There was no collaborative way to do the code review, to deploy, to roll back, to release, to document. And as a result, we were facing a lot of data issues and incidents. We were using different infrastructure components on cloud, which was very high to operate. So it was costing us a lot of money. Latency was also an issue. Because of the cost, we were not able to run data more than once a day. We had limited accessibility patterns. For example, if somebody wants to get access to data, either they will see everything or they will see nothing. So we had a very complex tier architect to manage the roles and permissions. And the poor data quality. We didn't have any inbuilt test built in because we didn't have DBT, of course. And then we were facing a lot of issues in terms of data quality, the test, the pipelines are failing, and all that. And then how we were managing the transformations through stored procedures, which comes with their own set of challenges. So stored procedure is a monolithic way of building a transformation, and that comes with their own challenges. Lack of traceability. We have stored procedures, thousands of lines of code, which was so hard to trace and debug. Difficulty in testing. You need a very specialist set of skills, and specifically the owner of the stored procedure is the only one person who can really can understand what's going on. Debugging challenges. So especially when we had issues, it takes us hours and hours and even days to figure out what's going on because the files were so complicated that it's not easy for someone to really go and understand what exactly the root cause is. Version limitations. We were not using any version control, and as a result, we were not using any best practices of version controlling. Maintenance overhead. You need constant set of skills and effort to maintain the models, to make it more performant, make it more optimized, which was taking away a lot of time. Code duplication. As you know that stored procedures are monolithic, so we had a huge chances that same piece of logic is basically written in different files. And when we have to make a change, we first have to identify where else this code has been referenced. And then logging errors and limitations. So then we thought that we need to do something different. And then we start to evaluate some tools on the market, and then the DBT came to our mind. So the moment we implement DBT with a powerful database like Snowflake, we start to see benefits immediately. We had improved accessibility. So DBT have inbuilt role-based access control method, which can be linked to SSO, SAML, Active Directories. So you can easily manage different granularities of roles and permissions. So it's not like either a customer will see everything or nothing. You can manage the granularity on the level of data and on the level of columns as well. Modularity and reusability. So this has become really important because we wanted to treat analytics as a piece of code, not something that is sitting in the back end and no one has visibility. So analytics as a code allow us to build models as a software entity, which we can reuse using a DRY principle. So if a piece of logic is built, rather than building the same piece of logic everywhere, it's being referenced in different places wherever it needs. Testability. So DBT comes with a lot of testing capabilities. Inbuilt test, custom test. So based on your use case, you can build a lot of tests, and then it is able to catch the test beforehand so that we were able to inform the customers that something is wrong and we are working on it. Documentation. So for the business users who want to understand the metadata of the data, DBT provides a lot of value in terms of documentations. So we were able to capture the documentations about what this table means, what the columns means, how this metric is being calculated, and we push it to DBT documentation so that people can come and see what data is all about. Lineage and impact analysis. So with the functions like ref, we was able to build a huge lineage type of models so that when we have to debug, we at least know that what other models could be impacted because we can see the upstream and downstream dependency of the models. Incremental build. So DBT have a lot of build strategies. So we use incremental build, which allow us to only load the delta, which was last change, instead of reloading the whole data every time. Jinja templating. So they have a code as a functionality features like a Jinja, which you can basically build macros and a lot of customizations based on a use case and use as a function like a UDF or a Python function. And a semantic layer, which is now coming. So semantic layer, this is something we are currently evaluating and exploring. This will allow our business users, to maintain a consistent layer of metrics, a consistent layer of definitions, so that you don't go into those cases where different people are counting the same metric and you have different numbers. So after implementing DBT and Snowflake, there was some accomplishments that we saw, and I really want to share those numbers. We were able to reduce our operating cost by 89%. Time reduction to debug an issue was reduced by 90%. Instead of now searching through stored procedures, we can open up the lineage, even the model level lineage or the column level lineage, and can understand which file exactly have the issues. we were able to decrease the compute cost by 70%, even though we were running the models more frequent than before. So when we were on our legacy infrastructure, we were running the models once a day. Now we're running the models every 2 hours. Even with that, we were able to reduce our computing cost by 70%, because now we're loading the delta we need. Reduction in latency, so from 24 hours to 12 hours, and now to every 2 hours. And on the right side, we have some numbers based on the metrics we run on dbt. We run around 70,000 models every single day in dbt. We work in a multi-tenant environment. We have different environments of dbt, dev, test, production. We have different clients. And we run the jobs every 2 hours, and we have huge models. So on average, we run 70,000 models on dbt every single day and counting. 100% of our transformation models is built using dbt. And we process around 200 million records every single day with dbt and growing. So there were some best practices and lessons learned that I want to share with all of you, so that is this something that you are looking to apply? These are the nuggets you can take and evaluate and see if it can help you. Embrace SDLC and CI/CD. We'll go through each one in detail. Leverage incremental features. Leverage macros for code reusability. Add testing. Choose your materialization wisely, and adopt a style guide. Embrace the SDLC and CI/CD. It allows us to operate the data as a code. It ensures that you are building the code in a very structured manner. It accelerates deployment cycles. It treats code as an ownership of the team rather than an individual. You can track changes and work more collaboratively. Leverage incremental models. It allows us to have faster build, improve performance and latencies, and also reduce the processing costs that the numbers I was sharing earlier. Use macros for code reusability. So macros are just like a function. If you're familiar with Python, it's just like a functions. Building macros will help us to not avoid duplication work in different code. You can just call the function, and it will produce the same output, and you can refer it to any model you want. Add test. It helps to improve the data quality. It helps to catch the issues earlier before the pipeline builds, and the user can start to interact with the data. Choose your materialization wisely. There are different types of materialization provided by dbt. Views are good for small data set, which have very minimum transformations. Tables, good for large data set, substantial transformations. Incremental, when you're doing a big data processing. Materialized view is more like a Snowflake managed increment models. Or ephemeral, if there is something you want to build and don't want to showcase to the clients. Adopt a style guide. So style guide becomes really important in a company, especially when you're looking towards scalability. There's no right or wrong way to adopt a style guide. The only important thing is it should be consistent. And it should be something that everybody can follow and you can scale. It enhances the readability because now you have a standard of naming conventions, documentations, debugging standards, and all that. It promotes peer collaboration. It helps easy onboarding of any new employees in your team. Some examples that we use is SQL linter, like SQL Fluff, the project structure to help organize our data into different logical layers. We use something called Medallion Architect, so it's like bronze, silver, and gold, and naming conventions. So that's it. Thank you so much. I hope this is something helpful, and I'm here for any queries if you have. Thank you.